Welcome to an introductory demo of LogicGem 4.0, our AI-enabled decision table processor. This demo will show you how simple it is to build and validate the completeness of your decision table, generate source code in your target programming language, and even develop in a natural language the documentation of your source code. This demonstration shows how to use LogicGem to represent and complete the logic portion of a programming project. We'll start with a description of the business requirements and then demonstrate how to incrementally build a table to represent the logic. Once the table is logically complete, we will finish up by generating the programming source code that can be integrated into a software application and also generate detailed documentation of your source code for your files. Let us assume that a business provides different discounts based on various characteristics of the customer and the purchase. First, a special discount is assigned to new customers making the purchase. Second, a discount schedule is applied to existing customers based on the sales amount of the order, where a bigger discount is given for larger orders. Your requirement is to program the logic for calculating a sales discount. The discount is to be based on these two business requirements. In addition to coding this discount schedule in the programming language of choice, you really need to make sure that all conditions have been considered. Usually, a developer attempts to convert business rules such as this without any special tools. The resulting code for simple projects like this one has a high probability of success. However, for complex sets of requirements, it becomes increasingly likely that some rules will be missed, resulting in incomplete and fallible program logic. LogicGem can be used to guarantee that all cases are addressed. Now, let's use LogicGem to develop the required program logic in a way that we're 100% confident the code will be complete. That means no rules missing, no redundancy, no contradictions, and no ambiguity. The following are the business rules we've been requested to program. 1. New customers get the highest discount as incentive. 2. Small sales get no discount. 3. Mid-level sales amount gets 1% discount. 4. Higher sales amount gets 2% discount. LogicGem will open with a new table. At any time you would like to open another new table, simply click the New Decision Table button. We resize the table by grabbing and pulling the grid lines. A table is not a spreadsheet, nor does it function as one. A table is divided into 4 quadrants. The upper left for condition stubs, the upper right for condition entries, the lower left for action stubs, and the lower right for action entries. Each column containing condition entries and the corresponding action entries represents a rule. We start by entering all the conditions that we can think of. Since this is a programming example, the condition stubs must be valid logical expressions of the target programming language. In our case, Python. Therefore, we fill in condition stub 1 with new customer equal true. Double-clicking the next line allows us to enter the second condition, amount of sale less than 500. We now enter condition 3, 500 less than or equal to amount of sale less than 1,500. And finally, we enter condition 4, 1,500 less than or equal to amount of sale less than 5,000. Now we enter all the possible actions we could take in the action stubs. Action 1. Discount amount equals 0. Action 2. Discount amount equals 1% times amount of sale. Action 3. Discount amount equals 2% times amount of sale. And finally, Action 4. Discount amount equals 5% times amount of sale. The completion ratio in the taskbar at the bottom is showing us that based on the number of condition stubs we've entered, there are 16 different rules possible. The 0 in this ratio is telling us that at the present, we have no rules listed. Now let us describe the business rule that this column will represent. We have already reviewed the 4 business rules we were requested to program. Now we can describe the first rule here. New customers get highest discount as incentive. Now we represent this rule in column 1 by indicating the actual state that each condition must be. Based on this rule's description, the first condition must be true, so we enter a Y for yes. Since a new customer gets the highest discount, no matter what they spend, We enter a dash indicating we don't care what the other conditions are. To complete this rule, we must select the action or actions that should be invoked, given these sets of conditions exist. Since this rule indicates that a new customer always gets the highest discount, we place a 1 in this column on row 4. In a more complex problem, we might have a series of actions invoked for a rule, in which case we would number them off in the order they should fire: 1, 2, 3, etc. Let's enter the second rule description now. Small sales get no discount. We'll define the conditions and actions now for Rule 2. The customer is not new, so C1 equals N for no. Since Rule 2 states small sales, C2 should equal Y for yes. Therefore, we don't care about C3 and enter a dash, and a dash for C4. Since this rule states no discount, we select a 1 as the action. We now enter the third rule description. Mid-level sales amount gets 1% discount. C1 equals N, not a new customer. C2 equals N, since the sale is more than the minimum. C3 equals Y, since the sale amount is mid-level. And finally, C4 equals a dash, since we don't care. This mid-level sale rule calls for a 1% discount, therefore we enter a 1 in A2. We can now enter our last rule description. Higher sales amount gets 2% discount. Again, C1 equals N, not a new customer. C2 equals N, since the sale is not small. C3 equals N, since the sale is not mid-level. And C4 equals Y, as it is the highest sale figure. This rule states that higher sales get 2% discount, so action equals A3 to complete our last rule. We thought we were done, but look at the completion ratio. It is showing us that of the 16 unique rules possible, our table is only representing 15. A rule is missing. Let's select the Logic menu. Selecting Missing will cause LogicGem to look for the missing rule. LogicGem has found our missing rule. Click OK to add it to the table. Oh, we overlooked the case where an existing customer spends more than $5,000. LogicGem determined that and added the rule for us. Let's describe this newfound rule now. Large sales over $5,000 get 5% discount. We select action A4, since sales over $5,000 get 5% discount. The completion ratio equals 16 and 16. Therefore, all possible combinations of conditions are represented. Our logic is complete. Click the Compile button and LogicGem will translate the perfected table into Python source code. At the same time, your Python code is automatically written to your file system and ready to be inserted into your program. Now, with just a couple of clicks, LogicGem can also create detailed documentation of your source code. With a simple check, let's add rule numbers to our code and include a copy of the logic table in our code. We'll also include the rule description in the code. Now, let's open the language combo box. Let's scroll to English. And now we'll select English for our documentation. We could also create our documentation in French, German, or Spanish. Finally, let's select a rule list structure instead of the nested if, else. Simply click Compile to generate detailed documentation. All of the data from our perfected LogicGem table is inserted at the top of our documentation. Scrolling down, we see all the included comments in our source code now. Our code segment includes rule descriptions and numbers, all in an easily readable rule list format. Thank you for watching this introduction to LogicGem. You have only seen a small selection of the powerful features available with LogicGem. In addition to optimizing your code, LogicGem can also help you with completeness, ensuring all of the conditions in your decision table are being covered, eliminating contradictions, making sure rules with the same conditions won't result in different actions, fixing redundancies, preventing rules with the same conditions from resulting in the same actions, resolving ambiguity when a reduced decision table has contradictions or redundancy errors, and much more. Go to our website at logicgem.com and you can download a fully functional evaluation copy of LogicGem.